Welcome. Hi, everyone. Bonjour à tous. Welcome and thank you for joining us today for this new edition of the Café des Sciences. I'm Maëlys Renaud, the Deputy Attaché for Science and Technology in LA at the Consule Generale of France in Los Angeles. I am very excited for this event tonight. We have a very, very special guest with many talents, Aurélie Jean. Thank you for being here with us. Before giving the floor to the Consule Generale in Los Angeles, Julie Duhaut-Bedos, I would like to say a few words, and I'm really pleased to have as our co-partners the Alliance Française de Los Angeles. We are live here today in their headquarters. It is our first hybrid event with attendees watching from the comfort of their homes, offices, maybe backyards or even cars, as well as a few attendees here in front of us at the Alliance Française de Los Angeles, respecting the COVID-19 safety policies. Thank you, everyone. And thank you for this new experience. And our other co-partner, Los Angeles Accueil, with whom we're really enjoying having those Café des Sciences together. This event is supported by the Consule Generale of France in Los Angeles, and I give the floor to Julie Duhaut-Bedos, French Consul General.
Hello everyone, bonsoir à toutes et à tous, bonsoir à vous, dear partners, dear guests, dear online guests. C'est un plaisir pour moi de vous accueillir pour cette nouvelle édition du Café des Sciences, qui est un événement qui permet de discuter des découvertes scientifiques, de la recherche scientifique, des nouvelles scientifiques avec des scientifiques français et des experts. Merci à tous pour votre présence, pour cette édition qui est réellement exceptionnelle, avec une scientifique française de premier plan, reconnue internationalement, une chercheuse, une experte et une femme entrepreneur, Aurélie Jean. I'll switch to English now for our friends. It is an honor to welcome Aurélie Jean today for this very exceptional edition of the Café des Sciences. Café des Sciences is an event where we discuss scientific, technological innovations, news, research, and discovery with French scientists like Aurélie and experts. Aurélie Jean is a leading scientist, internationally recognized, a mathematician and an entrepreneur, French word. Aurélie embarked on what we can truly call a mission to demystify the algorithms, coding, and science in general. She is, as you will see during her presentation, she is passionate, bold, committed, and I have to say I'm very impressed by the way she manages to navigate between research, teaching, writing, and consulting. Aurélie is the founder and the CEO of a company called In Silico Veritas, and she recently started a deep tech company in the field of precision medicine for breast cancer in Tel Aviv. She is also, I have to say, an inspiring model for young girls and women who are attracted to scientific studies and careers, as well as those who do not dare to consider those studies. And seeing your example, Aurélie, I am convinced that many girls will now dare to go into scientific careers. Thank you so much for accepting our joint invitation with our partners Alliance Française de Los Angeles and Los Angeles Accueil to be our guest speaker today. We are very honored and thrilled. Before diving with you, Aurélie, into the world of algorithms, a world unknown for many of us, and me especially, I'd like to warmly thank the Office for Science and Technology in Los Angeles, whose mission is not only to develop the scientific collaborations, but also to share accessible and high-quality scientific knowledge. And this is precisely the purpose of this Café des Sciences, to share scientific knowledge with the general public. And it is a mission of our consulate that I'm very attached to personally. And I know, for having discussed this with you, Aurélie, that you also are very willing to participate in democratization, the democratization of scientific knowledge through online conferences like the one we are doing today, the articles you publish on media, the books you write, and I know you have one that will be released on the 6th of October, so that's the new one you have recently written, and everything you do on social media. And I encourage all our friends learning French to read Aurélie weekly chronicle in a French media called Le Point. It's online, and it's a great way to practice your French. One last thing, a huge thank you, un très grand merci to Maëlys Renaud from the French Office for Science and Technology here in Los Angeles for having organized the conference today. Thank you very much, and I wish you all a great evening, a great conference, et bonne conférence à toutes et à tous.
Thank you. Thank you, Julie. Thank you for this introduction, and I would like to invite our partners, and Isabelle, you're first on the stage tonight for Alliance Française.
Thank you, Maëlys. Isabelle Leroux, I'm the president of the Alliance Française de Los Angeles. So it's always a pleasure to welcome Le Café des Sciences in our offices. Thank you, Maëlys, for having organizing everything, and also to partner with our longtime partner, Los Angeles Accueil. After 18 months of closing, we are back. So it's a true pleasure to have you in person and to have people on Zoom, our first hybrid event. So it's really remarkable for us. We are very happy to be back. So next Monday, it was back to school for the Alliance Française. We have now 2 offers. It means that we have the online courses, and in addition, you can have now a few classes in person. Another change is the Saturdays. Now all our Saturdays are dedicated to the youth, so kids and teens. It's a true day for them, meaning that you can have French classes and you can have also French activities. So thank you everyone for being here in person and on Zoom. And I hope that is just the beginning of more events like on this type.
And I have the pleasure to welcome Véronique Mingard for Los Angeles Accueil.
Merci Maëlys. Bonsoir à tous. Hello. My name is Véronique Mingard. I am the president of Los Angeles Accueil. We are a non-profit French association. The word accueil means roughly to welcome. And this is exactly what we do. Our mission is to welcome and to help integrate the French-speaking people who come from all around the world, expats who come and settle in Los Angeles. We also cater to a lot of French people who live here and have lived here for many years, and French speakers, Francophones, Francophiles, everybody who loves France, everybody is welcome, who wants to keep in touch with our French culture and speak our beautiful French language. À tous les membres de Los Angeles Accueil qui nous ont rejoints ce soir, virtuellement, bienvenue. Et merci beaucoup à notre consul général, à Maëlys Renaud, à Isabelle Leroux, de nous recevoir ici ce soir. Merci beaucoup.
Thank you so much, Véronique. Thank you so much, Isabelle. It's time to dive in the world of algorithms with you, Aurélie. You have the floor for maybe half an hour, and then we will open a Q&A section for 15-20 minutes. So I welcome everyone that is on the Zoom to use the Q&A feature so we can interact after and continue the discussion. Thank you so much.
Thank you. So first of all, thanks to everyone who attended the session online, here in person. Thank you, Maëlys, because I know you've been working a lot, very hard to make this happen. Thank you to the Alliance Française, and thank you, Julie, because because you've been helping me every time I need it. So you really, you help the people, the French people who live in the area. So really thank you. And you help the country, you know, exists, like France exists out of the borders, of course. So today, so obviously I have a lot of pressure after this introduction, so I'm going to try to do my best. So tonight I'm going to talk about algorithms and the world of algorithm, my world, part of my world actually, and what I'm doing in my work, in my research, teaching and writing. And I'm going to try to explain you why we should all become power users of technology. So why we should understand the underlying mechanisms of the technology we've been using, and also how. And hopefully by the end of this presentation, you will be convinced and you will try to better understand, ask questions, and maybe, eventually become a power user of this technology. So because we are in Los Angeles, I had to start with, hopefully it works. Yes. So I had to start with movies, because we're in Los Angeles, Hollywood. So, and I am a huge fan of movies, obviously. So, so I had to start with that slide. When you think about algorithms, you think about artificial intelligence. You might think about robots, you might think about data, you might think about sci-fi, and I'm a huge fan of sci-fi. So here are a few examples of movies that I love, like also books, because Minority Report is actually initially a book, as you might know. So those movies have a common denominator, which is they are referring to some concepts that exist or don't exist, or might exist in the future, or might not exist in the future, about AI, algorithm, data, science in general. And why do I put that slide? It's because I've met so many people talking to me, asking me questions by referring to those movies. Like, oh, this is like in that movie, there is blah, blah, blah. And I say, well, this is a movie. And which is great. It's like love stories. It never happened that way in the real world, right? I mean, at least from my view. But so, well, it's the same. So I try, but I like to play with those movies to attract the attention of people and to explain them what's happened. And at a point that I did a podcast a year ago, and I developed that podcast for Magellan, that is a podcast producer in France, co-founded by Mathieu Gallet. And we did that. We had this idea to say, okay, let's use movies, novels, TV shows on sci-fi to actually explain people. So each episode is a movie, a novel, or a TV show. Let's explain people what exists, what doesn't exist, what won't exist, and what will exist and why. And you might be surprised, but for instance, Minority Report, I don't know if you've seen that movie, but it actually exists. There is an algorithm and technology that was developed here in Los Angeles at UCLA, and that was used by the police of Los Angeles for many years. It stopped like in 2020, April 2020. It was a technology to actually predict in the next 12 hours where to go for the police, the police of Los Angeles to find criminals, So believe me or not, things exist, but then it's a matter of like understanding really what they do, how they do it, what are the failures, and how we can do to improve those, and whether we have to use those. So, so it's not as fancy as my previous slide, but stay with me. So here I'm gonna first explain you the difference between algorithms. So when we talk about artificial intelligence, we talk indeed about algorithm, because an artificial intelligence technology, AI-based technology, is actually using, algorithms that run over a set of data to actually provide an answer to a question, or to provide an explanation about mechanisms of a phenomenon, or even to make a prediction. Okay, so I like to actually distinguish two types of algorithms. This is the things I've been doing for many years. I've been explaining that to students. They are what I call the explicit algorithms and the implicit algorithms. So algorithms are pretty old. I'm not going to go back to history, but are pretty old in history, like more than 1,000 years. But just for you to understand, an algorithm is literally a set of tasks, of operations to be executed to, again, answer a question, solve a problem, provide information on a mechanism, or provide prediction. So that being said, today, when we talk about algorithm, we refer to computer algorithms, meaning not the ones that were made 1,000 years ago to be executed by hand, but the ones that are made to be executed by computers, meaning that we translate the algorithm into a computer code that runs on a computer to provide an answer to a question, for instance. So I distinguish explicit and implicit. Let me explain. So the explicit algorithm, which is the one on the top, there is a person like me, for instance, and I'm going to actually describe the logic of the phenomenon that I want to simulate, that I want to model. I'm going to express the logic manually, okay? And I'm going to implement that logic into a piece of code I might need to calibrate the algorithm over a set of data to define the value of parameters of constant. And then eventually I run this algorithm and I get an output. Well, this is, and obviously explicitly you define the logic and you define also hypotheses, conditions, etc., etc. In that part of the algorithm, there are the mathematical models. There are also what we call the structural conditions, conditional structures, sorry. So for instance, decisional trees, you may have heard about that, yeah. And then there is the implicit algorithm. So the implicit algorithm is actually an algorithm that in which you don't explicitly define the logic, but you actually implicitly define the logic by training the algorithm over a set of data that is usually huge. And the set of data that represent the scenarios, the situation, the phenomenon on which you want to, ask a question or solve a problem. So I'm going to explain you after. I'm going to give you some examples, but just for you to know, implicit algorithm is what we call today machine learning. I mean, we use that word. I use implicit because machine learning, people tend to think of machine learning is only deep learning. Not at all. There are many kinds of machine learning algorithm. I'm going to explain you the difference today. And so I like to say explicit, implicit, just because we understand that here we say we define explicitly everything, whereas here we define implicitly everything. So that it's a big challenge today in terms of explainability, as opposed to the explicit algorithm where we can most of the time explain really 100% of how the algorithm is running. For the implicit one, we tend to not and first shot to explain how it works. So we developed actually, many scientists and researchers develop explainability methods to calculate how the algorithm is running. So let me give you a few examples. So let's start with the explicit algorithm. So remember, in an algorithm in which we explicitly define the logic. So here's an example from my work, my previous work. I worked on the traumatic brain injury. And so I developed a model, an elastic plastic model of the brain tissue of human to actually understand the mechanisms of traumatic brain injury when the head of a human was exposed to a shock wave or a shock in general, blast wave, for instance. And so to do so, I had to develop a mathematical model to express all the degrees of freedom possible inside the brain to understand the relationship between the pressure that you prescribe and the internal deformation, if you can say. And so from that, I was able to write like a mathematical law to express the risk of mild traumatic brain injury, knowing the type of shock that a person has been experienced. So for instance, this model is used by the US Army today. So it's really relevant, as you can imagine, or even for the NFL or sport where, extreme sport, etc., etc. So here we explicitly define everything. There is a common example that you might not know, but the weather forecast. Every day when you look at the weather, even though in Los Angeles it's always sunny, so we don't need to check the weather, but in some areas in the United States or the world, you have to check the weather. So when you check the weather, there are actually every day there are calculation algorithms that are running, big calculation, big computation, believe me, that are running over physics, mathematical models that express the physics of air, the physics of water, wave, propagation, etc., etc. So it's explicit models, okay? So it's more common, so people might know what it is, and the computation believe me are very huge. And obviously here we do prediction, okay? So now let's go to implicit algorithm, the one that for which we don't really know the logic or the phenomenon we want to simulate. So we decide to, instead of trying to explicitly define how it works, we're going to try to get as many data as possible that describe the scenario on which we want to ask a question, or solve a problem, and we are going to train the algorithm over that set of data. So here's an example that I love, and I think it's pretty common today. Hopefully in 2 years from now, I'm not going to show that example anymore because we're going to be out of COVID, but it's a very interesting study that was made by a team at MIT. It was this year, I think, yeah. And this team at MIT actually was capable of training an algorithm over a set of audio recording of forced cough, of people who had COVID or not COVID, but the people who had COVID with no symptoms. So it's a way actually by by asking people to cough, or forcing cough, they can actually detect whether this person is asymptomatic or not. So it was interesting because explicitly you cannot really define what it is to have a cough that is related to the asymptomatic COVID, but you can actually train an algorithm to recognize what we call patterns. So in other words, there are patterns in the data that demonstrate, the existence of here the asymptomatic COVID. Another example that is, so Julie mentioned it at the beginning, it's a study that I did. So it's a small research project that actually became a company this year. It's our company DPEEX in Tel Aviv in Israel with Israeli collaborators. So in this work, what we have done, we have developed an implicit, a machine learning algorithm. We actually have developed an hybrid. So there is also an explicit part, some mathematics, but it's an hybrid machine learning algorithm that can detect what we call the signature of a breast cancer, meaning that we can detect literally thousands of cells, a signature, a weak signal, if you want, a weak signal of the cancer 2 to 3 years before you can actually see the tumor on the mammogram. So again, explicitly, we could not really define what is a weak signal, what is a signature of the breast cancer. As the same, you cannot really define explicitly what is a tumor on the mammogram, it's hard to define, but implicitly, you can actually train an algorithm to be capable of detecting those by recognizing patterns, because at the end of the day, the training is just a statistical optimization. So now, why we should all become power users of technologies? Well, the examples I gave you, beside the weather forecast, which is not really threatening, right? I mean, if there is a mistake, it's not a big deal. Well, you have to become power users of technologies because you interact on a daily basis with AI-based technology without realizing it. And you have to be aware of that because that way you can decide how to use a tool, whether to use that tool instead of another one, and also to ask questions and to defend your rights, as I like to say. So to actually make you aware of how much you interact with those technology, I try to simulate what you could have done before coming here today, okay? So let's say, this is the afternoon, you say, okay, I have to go to the Alliance Française for that speech. So, let's remind me what is just to make sure that it's today and the time. So you go to the platform, the website you used to register. So you check that you are registered, the time, everything is good. Okay, good. Then you're like, let me go back to the email, just to make sure that actually I respond in the email. So you go to your mailbox. So this is a mail from Mailist to a friend of mine who couldn't come tonight, Mathieu. But so, and so just to check that, okay, I said yes to the email, so everything is fine. Then you say, okay, and you go to Twitter, you go to see the tweet, say, hey, this is a tweet from Julie Duhaut-Bedos, the French consulate, and say, oh yeah, this is true. So this is 5 p.m., and this is great. I'm going to go there, blah, blah, blah. And then you say, okay, you have to go to the Alliance Française. How do I go there? So you check on any, street map to check the route to go to, the directions to go to the consulate, and when you had to leave. So you are using a lot of things. And maybe, and this is for me, you might have visited an e-commerce website, like Ginette. I don't know if you know Ginette New York, and it's an amazing brand of jewelry from my friend Frédéric Desmond in New York. And maybe you go there because you want to buy a gift for a friend, and hopefully the friend is me, but we never know. So, well, my point is that you have been visiting so many things you don't even realize it, And my point is that those technology that you see here actually contain some algorithms, more or less advanced, don't get me wrong, but more or less advanced. Some are very simple, others are more complex, and they are running over a set of data that is usually the data from your usage and your profile. And so the idea is that you have to understand how it works to make sure that you're using those technology well. So from now, what I'm going to do is I'm going to take an example, and I'm going to explain you which kind of algorithm are running there, and so you understand what's happening and how you can become a power user of this technology. And obviously the answer is not to, because sometimes people say, okay, I don't go to social media, I don't use internet, I don't have any connected device, I don't use a computer. I say, oh, okay, well, I think it's not the answer. The real answer is something in the middle. We can take advantage of innovation while protecting ourselves, while protecting others, while making sure that we are still in a fair society. So it's a matter of balance. So I prefer to keep my computer. So I'm going to start with an example of implicit. So I'm going to talk about implicit algorithms only because they are very powerful, and those are the ones usually that are using a huge amount of data. The ones that are also the ones that are less explainable. So it's interesting to understand, how it works. So I'm going to start with what we call implicit clustering algorithm. So what is that? It's a machine learning algorithm, obviously. And this algorithm is going to create clusters by statistical similarities. So let me give you an example. Let's take Twitter, okay? And I have nothing against Twitter. It's just an example. You could take anything else, but I think it's very powerful because everybody can see how it works. So I am on Twitter. This is my account, and I'm looking at who on my account of Twitter, I actually follow people. I follow a set of people. So here I follow like Deva. I would recommend Deva Newman. She's she's the director of the MIT Media Lab. She's amazing. I recommend her. Some people like, for obviously Kamala Harris, Rachel Maddow, I love her show. So, I follow people. Then I actually like and tweet post on Twitter, So here it's a tweet about a movie that's going to be out in October in Italy and hopefully soon by Amanda Stairs, who is a friend of mine, a very famous French movie director. So as you can see, I put a lot of my friends in the presentation because I want to, to support them. So I like it and I retweet it because I love her work and I want to see that movie. I want everybody to see her movie. Then I'm like, okay, and sometimes I can answer a comment, a post, like this is a post from Eric's, on something that was very interesting about the idea of taxing robots. So, so in other words, I have a profile on Twitter, which is my name, maybe first name, or an ID that is related to my profile, the location, if I provide the location where I am, etc. But, and also all the words, that are part of my description. Then there is my behavior, which is who I follow, who's following me, the posts that I write, the comments I do, what I like, what I retweet, all those things together are my behavioral profile. Well, there is an algorithm, the clustering algorithm is going to do the following. If you run the clustering algorithm on that platform, what it's going to do is going to create clusters. So I will explain this, but clusters of users, okay? So here, I tried to make it very simple because then it can be really complicated, but it's each axis that you see here is a dimension. The dimensions could be, for instance, I don't know, the number of people you are following, the number of people you follow, that follow you, sorry, the sentiment of your comment, because there is sentiment analysis algorithm to say whether it's positive, negative, or neutral. It can be, for instance, the time, at which you post the most, different dimensions. And actually, we take all the users of Twitter, not all of them, but a certain amount, and we can actually create clusters of people depending on their behavior. So at the end, what we have, it's an optimization problem. At the end, what we have clusters in which, for instance, in the cluster C1, we have users that are similar. Similar meaning that they behave similarly the same way on Twitter, okay? So why do we do that? We do those algorithms that are amazing, believe me, I use those, for instance. We use those because then we can actually suggest contents. If I belong to the cluster C1, the class C1 here, Twitter, the algorithm is going to suggest me contents or follow or even people to follow that belong to the same cluster, and that the algorithm is going to suggest me a content, a post, that I'm going to see on the feed that people in my class like in general. Most likely, I'm going to like it. Okay, so you understand the idea. The clustering algorithm is used to classify people by similarities, and then we can better suggest them content. The idea is amazing, and I'm using that for some other things, but I'm using those algorithms, they're amazing. But there is sometimes an issue that what we call, I don't know if you've heard about that, the bubble effect. So the bubble effect, it's a very, very strong phenomenon on social media. The bubble effect is the following. I belong to a cluster. I see things that people on my cluster see. And at some point is, depending on how the suggestions are made, if the suggestions are only based on this clustering and also how the clustering is made, well, the cluster might not change over time, meaning that they are rigid, meaning that if I belong to the class C1, in a year from now, I will still belong to the class C1. I'm not changing classes, and also the class do not change in terms of shape and the type of people that belong to. So because of that, at the end of the day, I am in a bubble because I observe the world the way people like me observe it. So it's dangerous because then, as you all know, fake news love those, because it's easy to propagate a fake news when you belong to a class of people who share the same information, who believe in that, and there is also the confirmation biases and all those things together. So it's important to know that. So it's an example of algorithm. Clustering algorithm are used intensively. I use those, I love those, but there are tests to do. There are tests to do regularly over time to check whether there is a bubble effect by checking the classes. For instance, a test that I do, I always have a proxy, like one data point, like a user. In that case, would be a user type. And I check the class to which this user belongs to, over time. And so I can check whether my bubble is rigid or not. So, there are things to do to check whether you are close and even to detect a weak signal of the bubble effect. So I recommend the book by Elie Pariser, The Filtered Bubble, which is really well done. It explains for everyone, how it works. And also from a psychological perspective as well, which I don't do obviously. Then there is the neural network algorithm. So I talked about the clustering algorithm. Now I'm going to talk about another type of machine learning algorithm, which is the neural network algorithm. You might have heard about deep learning, for instance. So the neural network algorithms, I'm not going to introduce everything because it's kind of, I don't have time, but the idea is that you have an input, you have an output. The output is a response you want to get, the answer you want to get. For instance, the question would be, is there any dog on that picture? Okay, the question is there any dog? The answer is yes or no. There is a neural network, literally some nodes, in branches. It's a virtual image, but some nodes. At each node, there are a set of weights, and the idea is that we train the algorithm over a huge number of data on which we know whether there is a dog or not. And there are pictures in which there is a dog and pictures in which there is no dog. And the idea is that we do literally we do an optimization calculation to calculate the weight at those nodes, to eventually get a neural network that represents the algorithm on which that we can use eventually to detect the presence of a dog on a picture. So let me explain it. It's a picture with a dog. Okay, you know that. It's hard to define what is a dog. And that's why we use neural network and we don't use explicit algorithm, because you could say, oh, it's easy. A dog has a fur, so it gives a texture to the image, because explicit algorithm for image analysis are, for instance, mathematical morphological algorithms. You can say, oh, there is a fur that gives a different texture. There are 2 ears, like a tongue, maybe, blah, blah. But you know what? You won't be able to detect a dog. It's very hard. And you know what? You might not be able to detect different colors of dog of the same species, same race, same type. And then, well, that's why we use neural network, get the level of abstraction so high that you can really capture whether there is a dog on a picture. And so, but now you have to be very careful on the set of data on which you train your algorithm. You have to make sure that the data, all the pictures that you put in the training data set, has enough pictures, is diverse, so you consider all type of dogs, and also you consider other things. Let me show you. So other types of dogs, it's obvious. So I'm going to put as many type of dogs that you want, but then you have also to train the algorithm to make sure that it doesn't, it makes a distinction between a dog and a wolf and a fox and a cat. So it's not easy, but it's possible. But to do that, you have to make sure that you give the good amount of data. And just for you to know, there is a very interesting paper that was made a few years ago about algorithm explainability, where they actually developed an algorithm to, I don't remember the team, it was from Toronto, I think, I don't remember. It's a team who actually developed an algorithm to detect a husky, a husky, a type of dog. And they realized at some point that the algorithm was detecting a use key every time there was mountain and snow behind. So they made a mistake because so they couldn't really detect a use key in Brittany or in Los Angeles. They actually made an algorithm to detect snow and mountain. So you see, so that's why you have to understand, and they were actually capable of seeing that because they applied explainability method. I'm not going to talk about that today, but there are methods to actually understand how the algorithm is running. So you can detect failures, you can detect biases, all those things. Sometimes it doesn't work. This is a very good example that I love to introduce. I don't know if you know this woman, she's an amazing scientist from MIT, Jago Rami. And she actually, so she's Black, as you can see, and a few years ago, it was in 2015, and she made an amazing TED Talk in 2016 that I highly recommend. And she actually was working in the Media Lab, working with an image facial recognition algorithm, the things that you've been using if you have a cell phone, you can detect your face, and to unlock the phone. And actually, she realized that the technology was not working on her. I mean, she was not working. So she said, oh, the technology, there is a bug. The algorithm doesn't work, blah, blah, blah. Then she realized that on her colleagues, it was working. At some point, she was like, oh, I don't really remember how she came up with this idea, but she was like, oh, I'm Black, they're white. So to demonstrate that, she actually put a white mask on her face, and the algorithm was able to detect her face right away. Don't worry, it's fixed now. But many years ago, it was not fixed. And many people thought that there were bugs in the technology, that technology was not working, but actually it was not working just on the type of people. This is what we call technology discrimination. The reason for that is that I don't know the algorithm, I don't know how it works, but if it was an explicit part, an hybrid, let's say it's an hybrid algorithm. If there was an explicit part that was image analysis algorithm, maybe the people who developed that algorithm didn't consider the contrast of images related to people with Black skin tone. And for the implicit part of the algorithm, the data that was provided in the training data set didn't contain enough, or maybe not at all, picture of Black people, which is really bad. And so then you can tell me, oh, this is, we have to blame the scientists and engineers who developed that, but it's not as easy. Just for you to know, if you look at the statistics of software developers in the US, obviously the women are pretty low, the Black people are pretty low as well, and this is something that we should be aware. And as Julie said, that's why we need to attract more people in those fields, because we tend to develop things based on our own perspective, and because we have biases, and we have to be careful with that. And that's why we have to test technologies, we have to intensively test technologies, and really also think about it before writing your first line of code, the first specification on the type of data that you want to collect to train your algorithm. So it's so in other words, and I in my first book I actually give an example. I gave an example where I actually almost discriminated myself, So, but I was aware of that. So since that experience, I know that I can discriminate. So I'm very careful. And obviously, because I'm a woman, and I'm more careful than as any other man in my field. And it's interesting because today, many scientists that are really working hard to make those technology better are women. So it's very interesting. I'm going to show you a few books. And so it means that the people who are the first victims actually work very hard to fix this problem. So in other words, I'm not better than any other else, and this is important to remember. So here it's a list of books that I really recommend. I mean, there are so many books, so it's hard to pick one, but there is a Filter Bubble by Ely Pariza that I really recommend. Weapons of Math Destruction by Katie O'Neill. I love that book. It's a little bit dramatic, so you have to, but I love it because Katie, I mean, I know Katie, she's an amazing woman. She's so powerful and she's very inspiring, and she really helps towards fixing those issues and developing the best practices and the right governance. Kate Crawford, you might know her. She works, she's a professor, and she was a researcher as well at Microsoft. I'm not sure, I have to check. And she published a book this year, Atlas of AI, that I really recommend with concrete examples. Technology Singularity, I love that book. Technology singularity is a theory, in AI and this book is really good because it demystifies everything. So I love it. Deep learning book, so I love it, but you have to be you have to have a PhD to read that book. But I love it because Joshua Bengio, I love Joshua, and he got actually with Yann Lequin, they got the Alan Turing Prize, which is equivalent of the Nobel Prize for Computer Science. Yann Lequin, so this is a book in French, Quand la machine apprend. I think it's an amazing book. Luc Julia, I don't know if you know him, is in San Francisco. He actually co-developed Siri. He was in the head of research of Samsung, and now he's at the CTO of Renault, if I'm not wrong. And so Luc is a very good friend of mine, and he wrote a book that I love. There is no such thing as artificial intelligence. And I love that book because it really explained that artificial intelligence is a bad word. And actually, Joshua Bengio, who wrote Deep Learning, he actually said once in 2016 in an interview at the MIT News, he said, you should never talk about artificial intelligence. We should talk about artificial stupidity, because we don't make the computer more intelligent, we make the computer less stupid. So I like that. And finally, there is this book, Artificial and Intelligence by Meredith Broussard, who is a professor in NYU. She's amazing, and this book is very funny. I like the examples that she takes. And all those books are made by scientists, engineers, who really know what they talk about. And believe me, it's not really sci-fi in those books. It's really about how it works. So it's very far from Minority Report or Her or 2001 Odyssey Space. But you know what? It is interesting because actually those people might be the best writers for sci-fi. And we know that the people who wrote some of those novels and movies are from the science engineering background. So it's interesting. And also, I put mine, if you don't mind. So I put my first book I published 2 years ago. So it's in French. So I'm working right now to publish it in the US. If you have any contact, call me. So I'm working with that, with agents. So De l'autre côté de la machine, which is really my own learning. I thought it would be interesting to talk and write about my own learning, so people can learn with me over the pages, about how I learned about algorithm. And today I just announced actually my next book that's going to be out in a month, Les algorithmes font-ils la loi? So in English would be, do algorithm rule the world? Obviously no. But the idea is that how we can avoid that. And the idea behind that, I talk a lot about regulations. I talk a lot about explainability. The idea is really, instead of saying, oh, we should not use that algorithm, or we should use that one and not that one. I think it's better to be in the position of like, okay, let's try to understand the level of explainability we can get out of the algorithm and try to understand whether there is any threat, for this specific algorithm. And I talk about transparency and the role of the tech actors, developers, engineers, scientists, obviously, but also state, big corporate, and regulator, lawmakers, and the citizens. Because again, I really believe that if we all become power users of technology, we are. I met once the CEO of one of the GAFAM, the big company, and I told him, you know what, your users are your best enemies, and he laughed. It was funny, and I told him, yeah, because you know what, if we challenge you, you're going to work better, you're going to develop better technologies, and I still believe that to reach that point, we have to become power user, understand how it works, to challenge those people to reject some technologies and actually embrace others. Yeah. So yes. So welcome to the world of algorithms.